Welcome to Ocean Academy. Today we are going to learn about thermodynamics. Now, what do you mean by thermodynamics? Thermo means heat and dynamic means flow. So we can say that the flow of heat or transformation of heat from one form to another or conversion of heat into energy is studied by the help of thermodynamics. That means if we want chemical energy is changing to heat energy or heat energy is changing to mechanical energy. So how these conversions are going on we can study with the help of thermodynamics. Now thermodynamics it deals with macroscopic system. So what do you mean by macroscopic system? That means a system consisting of large number of molecules. The laws of thermodynamic were applicable to systems which are in equilibrium or moves from one equilibrium to another equilibrium state. To understand thermodynamic, we should know some definitions of few terms which are going to be used largely. Now, definitions of thermodynamic terms. First, system. Now, what do you mean by a system? So, it refers to that part of universe in which observations are made. Or we can say assembly of large number of particles. The system is described by pressure, volume, or temperature. Example: a gas enclosed in a cylinder. So there is a gas tester with a cylinder. So example is a gas enclosed in a cylinder. So the gas that is enclosed in the cylinder will be our system. Now, so we can say system is that which we are going to study. Now, rest of the thing that is present outside of this system will be our surrounding. Like suppose we can, if it shaded with a different color red, so the dashed part will be our surroundings. So second term is surrounding. So it can be described as the remaining universe constitute the surroundings. So surroundings can exchange properties with the system. So our second term is surrounding. Now the third term is a wall should be there which is going to separate the system and surrounding. So the third one is our boundary. The wall that separates the system from surroundings is called boundary. A boundary can be real or imaginary. Suppose in case of a gas enclosed in a cylinder, so this wall of the cylinder and this piston wall, so this will be a wall. So you can get a wall that separates the system from the surrounding. System is this is our system. It is differentiating or separating the system from the surrounding. That will be our wall, that is boundary. Through this boundary, the flow of matter and energy can be controlled. Now, so this is our wall that I am doing, the black mark. So this is our boundary. So there can be flow of heat or flow of matter can occur between our system and surroundings, and whether heat will flow or matter, it is totally depends upon the type of the boundary that the system have between its wall and surrounding. The flow of matter and energy controlled with the help of boundary. And types of system. Now, according to moment of matter and energy in or out of the system is divided into three types. 1. Open system, closed system, isolated system. So our first type, that is open system. Now what happens in open system? Exchange of energy and matter between system and surroundings through the boundary occurs. इसका मतलब क्या है कि जो सिस्टम है और सराउंडिंग है, सपोज हमारा सिस्टम है एंड इसके जो सराउंडिंग है, सो सिस्टम के अंदर क्या है कि एक कप ले लिया हमने और इस कप के अंदर हमारा चाय है। सो जो टी कप के अंदर है वो हमारा हो गया सिस्टम, एंड जो बाहर का सराउंडिंग है वो हो गया सराउंडिंग्स। Now suppose if we place this cup on a stove, so what will happen? So flow of heat will be there. So heat is going from surrounding to our system. And next thing, since the T, that is present gas, some of it may evaporate and go to surroundings. So there is flow of matter also. So in case of open system, flow of heat and matter both can occur either from surrounding to system or system to surrounding. Heat can flow from system to surrounding or surrounding to system. So example of an open system will be liquid boiling in open vessel. So the next system is closed system. Now in a closed system, exchange of energy can occur but not matter. So in this case you can say exchange of energy but not matter. So the system in which the surrounding can exchange energy with the system, or the system can change between system and surrounding, energy can change or exchange but matter does not, that are called closed system. So example of a closed system will be a vessel with a closed lid. So this is your lid heating up. So when we are giving heat to it, so you can see there is a flow of heat but the matter is present inside this container only. So flow of heat is occurring but matter does not. So this type of systems is called closed system. And the third type is isolated system. Isolated system. So in isolated kind of system there is no exchange of energy or matter between the system and surroundings. So example of an isolated system will be a tea kept inside a thermal flux. So when it is isolated means there will be no flow of heat as well as no flow of matter, because the wall of the system were insulated, or you can say were isolated from the surroundings. Now state of the system. A state of a system is described by some quantitative value at some particular instant, like pressure, volume, temperature. That state is called thermodynamic state. Now, the thermodynamic state of the system is specified by state functions or state variables. So, this P, V or T which are going to describe the states are called state variables. So, P, V, T are called state variables or state functions. Now, why they are called state variable or state function? Because the value of P, V and T that does not depends on the path, they depends only on the state. So, you can say depends on the state of the system, not on path. So, state variables are the variables which depends on the state of the system, not on the path followed. So, they depend on the state, that means the initial state and the final state, and it does not depend on how they have reached from initial state to final state. They can follow any path, like this is your path A, path B. So, it is independent of the path A or B. It simply depends on the initial state and the final state. Non-state variables. So, we know that state variables which depends on the state of the system. So, non-state variables will be those which depends on the initial and final state along with the path also. So, you can say non-state variables depends on the state and path both. So, variables which depends on the initial state and final state along with the path, whether the path A is followed or B. So, such kind of variables were called non-state variables. So, example of these variables were like work done or heat. Now, based on whether the properties were changing when the system is changed or divided into parts, depending on that the variables can be divided into two parts. One is extensive and the second is intensive, and those which were exactly half were called extensive. That means if we are dividing the system into different parts, so that property is also getting divided by that time, so that will be called an extensive variable, and those were independent of the parts, like whether the system is divided into two parts or three parts, that are called intensive property. So, example of intensive properties or variables were temperature, pressure, chemical potential, specific heat. Extensive properties were number of particles, volume, energy, enthalpy. So, these are the variables which were going to change or get affected by changing the size of the system into two parts or three parts, where these are the properties which is going to remain same irrespective of the type of system, like whether it is halved or it is the original system. So, based on today's class, let me ask two questions. The first question, a thermodynamic system is classified as a closed system if it can. So, now that means you have to define a closed system. So, what do you mean closed system? Now, for this, you have to remember the different definitions of the systems. So, for this, goes to slide number 4. Now, in open system, what happens? The exchange of energy and matter between the system and surrounding occurs through the boundary. And a closed system. So, in closed system, what is there? exchange of energy but not matter. So we have to define the thermodynamic closed system. So there will be exchange of energy but not matter. So the answer of first question will be exchange of energy with its surrounding but not matter, exchange but both energy. So both, so this will be your wrong. So obviously B will be wrong, exchange neither energy, no, because it is not an isolated system. So this is also wrong. Exchange only matter, no, in a closed system matter cannot be exchanged, so it is wrong. So the answer that is correct is your A, that is exchange energy with its surrounding but not matter. Now the next question is a thermodynamic system. A thermodynamic state function is a quantity. Now you have to define a state function. So what is a state function? A state function used to determine heat changes? No. So this will be your wrong. Whose value is independent of path, used to determine pressure, volume, work. Whose value depends on temperature only. So state function. Now if you go to the definition of state variables, you can know state variables depends on the state of the system, not on the path. So based on this definition, you can find the answer of this question, that the answer, the thermodynamic state function, is a quantity used to determine the heat. Wrong. So this is your wrong. Whose value is independent of the path. So your B will be your correct answer for this question. So thank you. So in today's class, what we have discussed? We have discussed about thermodynamic, that is the heat of flow. Like what is thermodynamic? It deals with the transfer of heat from one form to another, or the conversion of heat from one form into another form of energy. Then we have studied about the different terms or thermodynamic terms which you used, like system, surroundings, boundary. Then we have discussed about types of systems, that like open system, closed system, isolated system, closed system. Then after this we have discussed about the state, like how the state of the system is described. So it is described with the help of variables which are called state variables and or state functions. So pressure, volume and temperature, these are called state variables. Now since whether say they are independent of the path, so they depend only on the initial and the final state, and those which depend on the path along with the state, they are called non-state variables. And at last we have studied about the extensive and intensive properties. That means those properties or parameters which we are going to change with when the system is going to divide it into different parts, that are called extensive property, and those which are going to remain unchanged with the change in the system will be intensive. Like whether we are dividing the system into two parts or three parts, these are called intensive property, like temperature, pressure, chemical potential, specific heat, etc. थैंक यू. अगर आपको हमारा कंटेंट अच्छा लगा हो तो हमें लाइक, सब्सक्राइब और शेयर करें. थैंक यू.